Welcome to Champions of Data and AI, brought to you by Databricks. In each episode, we salute champions of data and AI, the change agents who are shaking up the status quo. These mavericks are rethinking how data and AI can enhance the human experience. We'll dive into their challenges and celebrate their successes, all while getting to know these leaders a little more personally.
We're back with our next episode of the Champions of Data and AI. I'm your host, Chris D'Agostino, Global Field CTO at Databricks. Today, I'm joined by Yanyan Wu, Vice President of Data and Data Analytics at Mackenzie, a Business of Verisk. Yanyan and I will not only discuss the role that Canadian geese play in keeping you safe as you fly at 35,000 feet, but more importantly, we'll dive into the importance of having large amounts of diverse, clean, and high-quality data to drive new insights. We'll cover how modern cloud data architectures like the Lakehouse make it easier than ever to combine data sets, structured to unstructured, to execute algorithms in near real time. We'll also explore how the work she and her data team are doing is helping oil and gas companies run more efficiently and generate more energy to help fill the gap brought on by current global events. Let's get started. So Yanyan, it's great to have you here today. Thanks for being part of Champions of Data and AI.
Thank you for inviting me. Great to be here.
So let's dive right in. You've had a long career with data in energy, and you've got your PhD in computer-aided design. Can you tell us a little bit about what got you into data analytics, artificial intelligence, and kind of what inspired your PhD research?
Yeah, I think the answer probably will disappoint you because it's not planned. I go with my passion. So at the time, several years ago, I think it's about maybe 2014, 2015, the time that data was hot, but not as hot as today. I thought it was just fun to learn about the data, how to visualize data, how to analyze data, how to deal with the big data. That's how I get into it. And then somehow my career shift with my passion. So I used to be, as you said, as computer-aided design, I'm a kitchen engineering, a product manager, then eventually guided me through with the learning that I built up. So eventually shift to a data and AI world.
That's awesome. Yeah, so I studied electrical engineering, and as part of that curriculum, we had to do some mechanical engineering style work and do some of the CAD type capabilities. And it was always fascinating to me the types of systems you could model out and create 3D representations for. So we'll when we first got to know each other, you talked about designing aircraft engines. We'll come back to that. But how did the experience from working with aircraft engines and all of the data, did that influence your passion for even more data analysis and pushing you in that direction for your career?
Yeah, it's all, I have to say, all my career is about data. It's just in different formats. Just as you said, Chris, right? It used to be in 3D, in geometry. Now it's in manufacturing application design world. Now shifting to the energy data. It's different format of data. It's like structured or unstructured, but none of them is many time series data. It's now 3D. But along my career, if you look at all I'm doing is just deal with different format of data. It's just they're changing, but the philosophy is same. Actually, Chris, I like your major of EE. I know that's something that if you let me pick again, I probably was not going to, because they for EE major, you talk about how to do a noise removal, signal processing, frequency domain. That's something I think in future we should look into more in how to combine EE knowledge, expertise with data and AI. I would like to do more on that side. So maybe I can borrow your expertise down the road.
Well, my EE expertise is a bit dated, but yeah, in terms of, I spent my early career doing semiconductor design, sort of low level sort of physics type stuff. And then I of course studied computer science as well. So my career shifted, as like yours, shifted very much from the tangible real world, build something and actually something you could actually see and touch, to distributed computing software that runs on these machines and produces a result, but it's not the same as building tangible objects, which is something that always fascinates me. So in looking at, say, oil and gas and what you're doing today, we talked about when we first met and got to know each other a bit, we talked about the idea of, if you think about what's going on in the world in 2022 with a movement towards reducing carbon footprints, then that challenge gets worsened, if you will, by the fact that there's the Russia-Ukraine war, and Russia turning off pipelines to different countries that aren't in support of what Russia is doing. So these energy companies really have a big challenge on their hands. On the one hand, they've got to maybe add or supplement energy because there's less available energy from Russia. So they've got to provide more traditional sources of energy and do it in a more efficient way. And then at the same time, they've got to be thinking about how do they transition to cleaner energies and maybe completely alternative fuels. So, collecting the data for how they're running their current business and finding opportunities for investment to transition is a big part of your job, right?
Chris, you're right on. You're right on. That's how we got motivated every day to go to work, and all our mission is, because our goal is going to have a sustainable world for in terms of the energy demand and energy supply. It's not going to happen overnight. So what of course, we also want to go to green energy, renewable energy. I think that's the goal for everybody. However, it's not going to happen right away. So we still have to work with traditional energy, which is oil and gas, especially as you highlighted the whole that brought up by this Ukraine-Russia conflict, and that with that, I think the importance of making energy sustainable for the world through the traditional oil and gas business, especially, is extremely important now than ever. The lot of challenge that our clients and we have and the energy business have is how to improve the efficiency or improve the productivity for the traditional oil and gas business. How they do that, they have to have the data, right? So a lot of things, I think with my previous experience, what I see is every company has data. None of the companies say, I don't have any data. They all have data. The problem is, if you look at just data, your own data on its own, it's not going to be enough. It may generate some contents and some insights, but you get exponentially more value if you're able to link the data with enriched data from other data sources which run now Mackenzie and Verisk is providing. So our role mainly is with more enriched data that we're able to collect, we're able to help our clients to empower them to get bigger, more insights from the data they have.
Can you talk a little bit about the strategy within the company of maybe identifying these alternative data sets and these third-party data sets? Do you have talk a little bit about the team and how you do the ideation around, well, if we had this data set, we could maybe get this kind of insight that would help the oil and gas industry be more efficient or more productive. How do you and your team go through discovering what data sets make sense?
Yeah, the data is enormous right now. So actually, you don't have to discover. It's just throw onto you. It's a lot of data. The problem is how you prioritize them. How would you know which data source is better than the other, or which one is more important for clients? Otherwise, you're not going to have any time to sleep, to eat, because the data is enormous. So a lot of time we spend on is identify with so many data sets, which one is more important to our clients, and which one has a little bit better coverage and high frequency, and then maybe what strategy we have to use to combine the data sets. Just come back to my previous days with GE, with aircraft engine business. What we did, one of the projects we did is we call multimodality inspection. Basically, different inspection and NDE inspection methodology, it has different strengths. How could you get the best data sets? So you fuse the data together. We call about multimodality data fusion. We have a patent on that for my previous business. So the same thing as apply here for oil and gas business. You have to be able to come up with a way to fuse the data so you can have the best data sets for clients. So that's majority of time we spend on is understand the quality of the data for different data source and how to come up with a strategy effectively, efficiently to fuse the data together to provide the best data sets to our customer.
So let's talk a little bit about how technology in the data platform space has evolved over time. Since you've been doing this for a while and doing that data fusion, if your experience is anything like my experience, the data was stored in different systems. You could do some analysis on those core systems, but it was really difficult to bring data together at scale and run algorithms that would, give you new insights in a timely manner. Is that something that you've seen as well?
Yeah, if you look at through the years, remember your Excel time. Excel, everybody's on Excel, and Excel is the VB and Visual Basic is the best tool ever you have.
Yeah.
But I think a lot of people know, all those tools now has a limitation, right? The data is just, as I said, the data is growing. It's just exponentially growing every day and become bigger and bigger. Excel can deal with millions of rows very, very effectively, right? That's, I think, very effective tool to deal with. However, if the data is grow beyond that, we have billions of rows and hundreds, thousands of columns of those structured and unstructured data. How to find a platform that, to enable you to do those data quickly, right? If think about any automation or any data insights, if you want to debug anything, right? How can we find a tool that you're not waiting for hours, just get a line of the feedback and saying, to figure out if you are doing the correct thing or not correct thing. So in terms of those kind of capability, I think we find out Databricks is really a good platform for us to empower us to be able to effectively, efficiently deal with the big data, like billions and billions of rows, and also open up reduce all the the time that we spent, the time we spent in terms of how to link the data from different sources, right? With the Delta Lakehouse structure that, it really, you have metadata store on the Databricks. You can bring all the data transparency onto the same platform. Everybody see where the data is. It's there for you. You can do the time travel, so you don't need to worry about if I mess up with this version of data, can I get my older version back? Yeah, you can just call the previous version back very, very easily, and you can figure out with the auto load, all those capabilities. You can find out what's the delta of your data. So all those can be done that not very easily now on Databricks platform, and that's something that we cannot imagine before. And another one of the lot of benefits we gain from the Databricks is the efficiency through the scheduled work. So it used to be like, you have to get up certain day at a certain day, and in the morning and you start a routine. Now you can be automatic schedule and get informed once the job is done. So all those time that we save, now we can focus on improve our data quality, improve the data completeness, the timeliness, understanding the data insights, and getting the gold. Really started to use our expertise to dig the gold out of data we have versus just managing those logistics of dealing with the big data.
Yeah, we talked to a lot of leaders, and I is specifically in my role with the company, talk to a lot of leaders, and one of the common themes is returning more time to the user to do analysis. And so organizations are moving away from trying to do a lot of the infrastructure and the plumbing associated with data movement, with data cluster management and things like that, that they don't see that as providing competitive advantage to their organization. They say, look, we really want to not have to worry about the flow of the data and the availability of the data. We want to automate as much of that as possible. We want to really get our engineers and data science community and data analytics community analyzing the data and getting those insights and doing that more quickly. So that's real, very much consistent. So Yanyan, we have customers in the oil and gas industry. Shell Oil is a big one for us. Dan Jevons was on this podcast, and he's done a lot of speaking engagements, alongside Databricks in different forums. And so for those in the audience, we've got a great podcast if you want to listen to that. But would love to hear what you and your team at Verisk are doing, because, with Shell, for example, they were doing a lot around supply chain analysis. They were looking at equipment fatigue, and when they might need replacement parts for an oil rig. Your company is really providing a really cool service to the oil and gas industry. So without, maybe getting into specific customers, can you give us some sense of what type of support are you providing to oil and gas?
So if you look at Mackenzie's offer, we is a data provider, as well as we provide consultant service for energy investing industry. The data, as I said, one of the challenge of every company is they have their own data, right? Their own company data they know very, very well. However, they may not have the industry data that across industry that either their peers in the industry or related, even some of them related vendor information, they may not have it. So what we provide, that's where we step in. So we provide the data that they may not have on their own. So it's cross industry, across different companies, across different domain. That's one aspect. For example, if one operator is drilling in one region, if they want to know what happened to the other region, right? What's the productivity data? What's the return of investment? What's the cost data? We can provide to them, so they can use as a reference to benchmark their productivity, efficiency, and see if they need to move to other regions to invest. And then also another division, it's not my division, but another division will Mackenzie provide real-time energy data. So they have sensors, they have network everywhere. For example, they can measure the electricity generation across states, across counties at the real time. And the oil and gas production rates through measuring sensor from the pipeline and all this. So the real-time measurement data that is not available. For example, if you wait for government to report the data, which has a lag, right? It's not real time, maybe 2 or 3 months or whatever months it is for across different states. You get those the power generation numbers or oil and gas numbers or whatever energy related number that it has a lag. But with the business where Genscape have, they have real-time measurement, the sensors everywhere, and then they can provide you the real-time data related to energy business. So we fill a lot of holes for our clients that pockets of the holes that they don't have the data that on their own, that they can leverage the data we have, so they can create meaningful linked data sets to generate much more insights based on the data we provided.
So then these customers use these data insights and data products to, in theory, make decisions that really influence millions of dollars of investment from their end, right? So let's talk about data quality and the importance of ensuring that you're generating good data sets that allow you to create these insights.
Yeah, this is something that there's 3 themes that we mainly focus on. One is the timeliness of the data, and then the other end is completeness, and then the accuracy. So all this is key. All these 3 aspects, the key components for data quality. So it's not like just checking correct or wrong, but have to be timeless, has to be accurate, has to be complete. We spend a lot of time on this. So complete means, especially when you have big data, right, data sets, you're able to aggregate data from hundreds of thousands of data sources, that put them together and check them and look at their data profile, remove the noise, use efficient noise removal algorithm. You cannot just eyeball it. I have to have automated routine to do it. All this has to have a reliable platform. We use cloud providers platform, including Databricks, right, which is specialized in the big data processing, that enable us to improve the data quality to the point that without those tools, it's not possible to do.
Okay, so Yanyan, we're gonna transition to some fun topics here, that are just outside of the data space because of our, shared background in airplanes and passion for that. But in summary, it sounds like in your career, you've always been around data. You've been, following it as a passion more than something you just set out specifically to pursue. And so your passions have taken you into the realm of data and the different data analysis and different types of data sets and different types of insights. But the common theme is these organizations collect a lot of data. They have a lot of internal data. What you find yourself being able to do now is combine that internal data with external data sources and find ways to add value. And you're running a team to provide that for your customers. Is that pretty fair summary?
Yeah, it is, Chris. Just add to what you just said. It's exactly. I think the theme is always the same, right? No matter what role I was on. For example, I was at the time that I was doing an aircraft engine research project for GE. Now with Mackenzie on Verisk with providing data, energy data to our clients. It's all about how you get the data. How would you ensure that with the data that you have and you combine them and get the best data to you making the best decision. Just give an example. We used to have a patent application on this. It's called multimodality inspection project for aircraft engine. So basically, if you understand NDE, which is a non-destructive evaluation for inspection for aircraft engine, you have to find out different NDE modality has different strengths. Ultrasound is good at identify the layers. So delamination is something that I'm very good at. And X-ray is good at proximity identification. So if any density change is very sensitive to that. And coordinate measurement machine, CMM, is good at measuring the XYZ coordinates. So if you put them together, you get best data sets, right? We call data fusion, multimodality inspection at the time. The same thing as we are working now on the energy data sets. As I mentioned before, right? The data is enormous. And how would you combine the data from different data sets, different sources, and provide the best data to your clients? It's the same thing. It's also data fusion, right? So so it doesn't matter what it's in the 3D world. The data is in 3D, which geometry is 3D. That's my aircraft engine time. And now it's time series data, structured, non-structured time series data. But the theme is same. It's always about how you understand it, what's the strategy, can you build a team around it, build a strategy, identify the best platform like Databricks or other cloud providers, best tools to make you to understand your data more efficiently, be able to process data efficiently, and combine the data sets to fuse them to provide, so to enable the best data sets for your clients so they can empower them to make the best decision.
So, the thing that I love about, as you know, I like aircrafts a lot, and aircraft engine design. Like the thing that's fascinating to me about an aircraft engine, especially jet engine, is it is its own power plant, right? And all the things that we're talking about kind of globally with reducing carbon footprint is important there, right? You want these engines to be as fuel efficient as possible and the emissions to be as low as possible. So there's a lot of engineering that goes into the design of that. These engines obviously have to be reliable because you don't want the engine to cut off in the middle of the flight. And so part of that is, as you say, right, looking at the material science of how the fan blades are created and making sure that they're as lightweight as possible, but they're as strong as possible. And, there's the people that study aircraft design and things like that know that, birds are used to test aircraft engines. They'll run an aircraft engine in a test facility and a bird will go into it. But, I learned from you that it's not just any old bird. It's a very specific type of bird. So share with the audience what that is.
Yeah, it's aircraft engine probably is the most strict industry that I think everyone and work with, because it relates to life, right? Anything you do is related to the safety of the people. So if you look at, it's all about actually data tracking, right? So when I was working on the aircraft engine project, you go to those plants. It's fascinating. But if you look at it, it's all about data. Not like you make a bottle of water, you make a computer, and you probably everybody looks same. But for aircraft engine, every blade has a life certificate. It has a serial number. You trace it. You can trace it where the material comes from, when it was made, which step was processed. It has a certificate. Like the aircraft engine. It's the cleanest factory you can ever imagine. That I know it's better than my kitchen. It's very, very clean, and everything will track, and then everything you do has to be certified. But what do they certify? It's all about data, right? So so if you look at today, the energy business, that data we go with, it's more like it's different scale, because we're now tracking individual drill bits or individual wellhead. We're tracking a batch of the field that it's in the production. But then it's a different challenge, right? Then your scale of the data goes up. So in aircraft engine, the word is you have to make sure that the risk and each individual one has a lowest risk, including you have to shoot the Canadian geese and to the turbine base on ice and all this thing you have to done. But on now today's world, you have to make sure that on the massive data we have, and had to reduce the data quality issue, have to reduce the noise, making sure on the mass scale that the risk is the lowest for clients when they use our data, that they can be confident on the decision they make based on the data we have. So it's different, but doesn't matter it's aircraft engine or it's energy data or it's oil and gas or power plant. And if you look at the everyday, like majority of the people we work with is the data, is understanding data and how to reduce the risk for everybody, including life, based on the data we have.
Yeah, so that's fascinating. So for people that fly, you should be thanking the Canadian geese for your safety, is what you're telling us. So we also talked with Stuart Hughes from Rolls-Royce aircraft engines, and that podcast is interesting because of the way in which Rolls-Royce monetizes the aircraft engine. So if you're tuning in and you haven't heard that podcast, it'd be great to go there and go to our website and have a listen. So, okay, well, let's close it out. So, I mean, you've followed your passion in your career. This is fantastic. What advice would you give to people that are, they're hearing your story, they're learning about your PhD background and the research that you've done, the different organizations that you've supported, and now what you're doing at Verisk. Help us, what advice would you give to somebody aspiring to maybe be in your role one day?
Always follow your passion, right? Always. So I got a lot of people approach me, especially folks just started a career, asking, my advice and what do they do next as a step. I always give them a suggestion. Don't just gauge where you need to go based on how hot it is today. It's going to be hot today. It's not going to be hot tomorrow, right? Look at other frontier that you have passion with. If you're truly passionate about data, what I would suggest, if you're just like me, right? You're a mechanical engineer, you're double E like you, Chris, a double E major. What do you do? Take some class, take some actions. If you want to, and then don't think about it in this world, right? We're used to be like you just become a manager to lead your team. Now in the data world, not only data, in any technology world, that they need leadership, true leader who has the vision, like Steve Jobs and Tim Cook, so those guys. I think the people likes them not because of their managers, because they're very visionary. They are hands-on. They can do the work. They know the details. Elon Musk, he knows how to execute the project because he had the knowledge and he has the experience enable him to do it. And people view them as value added leader. So that's something that I would suggest anyone that aspiring to be in my role and going to be in the leader in the data world. You have to think about it. What can I do to build up my skill sets, my experience, so enable me to become a visionary leader?
Thank you for joining this episode of Champions of Data and AI, brought to you by Databricks. Thousands of data leaders rely on Databricks to simplify data and AI so data teams can innovate faster and solve the world's toughest problems. Visit Databricks.com to learn how data leaders are unlocking the true potential of all their data.